Alright guys, today is actually pretty short. We're going to be looking at how to look at some polynomial graphs with a calculator. And we're going to find some things that we couldn't find without it. So let's start with just some random polynomial function that has a few little curves to it like this. Not very pretty, but what we're going to look at here are what are called our local extrema. And those are basically going to occur in two different places. Now, I can't actually find the maximum point of this entire function because that arrow keeps on going up to infinity. But in a certain area, I can find what the highest points are, such as those 2 points right there. They're the highest point within a certain section of that graph because the top of those curve. Those 2 points are what we're going to call local maximums. Now we also, on this graph, are going to have these 2 bottoms of our curves, which we're going to call our local minimums. And these two things to combine together, the local mins and maxes, both make up what are called our local extrema. Now, in order to find these on a calculator, we're going to do that in a second, but all you need to know for right now is that the maximum number of these that you can have on a function is basically 1 less than the degree of the function. So we take our degree and we subtract 1. So if I have the function x to the 5th minus 3x squared plus 2x, the most number of extrema I could have, mins and maxes combined, would be 4. That's the max I could have. I don't have to have that many, but I couldn't have any more than that. Alright, so what we're going to do is we're going to look at how to actually find these exactly on a calculator. So what you're going to do is you're going to go ahead and graph this function here on your calculator. Alright, and after we graph that, we're going to look at it. And as you guys can see, you might need to change your window a little bit, but you should be able to see some curves for some low points and some high points. So this graph has 2 local minimums and 1 local maximum. And we're going to find what those values actually are. And the way to do that is we're going to go to second, trace, and if we're going to find the minimum, let's do the minimum value first. So let's do number 3, which is minimum, and it says left bound. So what we're going to do is we're going to move our blinking cursor to the left of the minimum we're trying to find and press enter. Now it says right bound, we're going to move our cursor to the right of that minimum point and press enter. It says guess, press enter one more time, and there's your minimum value, -2, 4. So same thing if we wanted to find the other minimum, we just need to move our cursor appropriately. Also, it's the same process for finding a maximum like number 4. So my cursor needs to be, when it says left bound, it's to the left of that point. And then I'll move my cursor for it says right bound to the right of that point. I'll press enter one last time. And there's that maximum. So that's the highest point in that curve. So it's a local maximum. And that's really it for our local extrema. The last thing I do want to review is just to make sure we remember something we haven't really done in a while. But let's say I have the function -x squared plus 3x minus 2. Just some random function here. Let's see if this one works for... Okay. So let's say I want to find the zeros of this function. Now if you guys can tell on here, it's kind of hard to see, but it looks like that graph does touch the x-axis. So I need to find those zeros. So what I'm going to do, there's 2 ways I could do it. The first one is go to second, trace, and go to 0. And it tells me again left bound, I'll press enter. Then I'll go to the right of that 0. And press enter. And it says guess, press again, it tells me my answer. That graph is going to cross at 1, 0. The other way we can do is if I go to y equals, I can make my y2 value 0, and then I can just see where these graphs intersect. And if you remember, we've done this before, and you can make that value anything you want. We just use 0 the most frequently. But if I do that, it's second trace, intersect, and my dot, whichever one it's closest to when I press enter, 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 that's the intersection it's going to give me. So that's just another way I could do that. And that's all there is for graphing with a calculator.